Hello and welcome once again to my channel. In this video, we are going to see the basics of small signal modeling of bipolar junction transistor. But before studying small signal modeling in detail, let's first understand that what is a small signal. For this, I am picking this term signal first. So what basic idea you are getting with the term signal? What is the definition of the signal? So signal is the core information, or we can say the message in the communication systems. We use the term message. So this is the information or the message which is given as input to the electronic circuit or the system, where the designer or the user is expecting some output. That output is calculated. If the calculation is proper and the system is efficient, highly efficient, then the observed output should be equals to the expected output. And the signal can be any entity like voltage, current, power, and the frequency. And what is the purpose of giving the signal? It is given to for the purpose of amplification, and we will study amplification of small signal by the BJT circuit in my upcoming videos. Now let's understand that why we are saying the signal small signal. As we know that in an electronic system we may have both AC and DC supplies. Usually this DC supplies or the voltage are used to bias the circuit. Now what is the biasing? I hope you know what is the biasing. It is used to operate the circuit at operating point, which is also called as Q point. Q is used for the quiescent. Quiescent means noiseless. What is the operating point? What is its significance? Let's quickly recall it. So here taking an example that this is the transfer curve of the common emitter BJT, and this is input, and this side is output, and this is the output characteristic. So we can say that this point is the Q point for this common emitter circuit. So the significance, the advantage of operating a circuit at the Q point, first is that the power at this point is half of the maximum power dissipated in the circuit. And the second advantage is that it is called as Q point. Quiescent, the noiseless, means distortionless. So this point provides the maximum linearity in the operation. Okay, अगर जितना सर्किट आपका linearly ऑपरेट करेगा उतनी ही उसकी efficiency भी maximum होगी. So overall सर्किट की efficiency best होती है at the Q point. So इस Q point पर ऑपरेट करने के लिए हम बाइसिंग करते हैं, एंड बाइसिंग के लिए हमारी DC सप्लाईज यूज होती है. AC जो होती है वो कॉमनली यूज्ड होती है इलेक्ट्रॉनिक सर्किट्स में फॉर द पर्पस ऑफ सिग्नल. बट व्हाई वी आर यूजिंग द टर्म स्मॉल सिग्नल? द एम्पलीट्यूड ऑफ द इनपुट सिग्नल इज गोइंग टू बी स्मॉल. डेफिनेटली वी आर कंपेयरिंग विद समथिंग. सो विद whom we are comparing that this signal is small or not? Are we comparing with the DC supplies which are used for the biasing in the electronic circuit? No. We are not comparing with the DC supplies. A signal is called as a small signal जब हमारी इस सिग्नल एम्पलीट्यूड की इतनी वैल्यू हो जो सर्किट को लीनियरली ऑपरेट करा सके. So a signal is small or not is again defined by the input-output characteristic of the circuit. This is called as small signal approximation. यहाँ पे हम approximation term यूज करेंगे, and this approximation implies that for small signal operation the signal amplitude, this is the signal VBE which is given as the input to the common emitter circuit. So the signal amplitude should be sufficiently small so that operation is restricted, or we can say the confined to an almost linear segment of the input-output curve. You can see that this output current is confined, this is restricted to the linear part of the transfer curve. जितना बड़ा सिग्नल आपका होता जाएगा उतना ज्यादा ये ट्रांसफर कर्व को कवर करेगा, एंड ट्रांसफर कर्व को कवर करने में लूसेस द लीनियरिटी एंड एफिशिएंसी भी लो हो जाएगी एंड डिस्टॉर्शन भी आ जाएगा. हार्मोनिक डिस्टॉर्शंस बढ़ेंगे, देन obviously power dissipation भी आपका increase कर जाएगा. So now we know that the DC supplies are used to bias the circuit. As you can see, there are two voltages, the VCC and the VB. For the amplification purpose, in which mode of operation we operate this BJT? Recall it. This is the active mode of operation, and in active mode of operation the emitter base junction should be forward bias, and it is forward bias with the VBE potential, and the collector base junction should be reverse biased, and it is done with the help of the VCC supply. Now this is the DC bias condition. Let's find out what will be the collector voltage and the current values. So it is very simple, just use the KVL. So VCE, or we can write it as VC because emitter is at ground. So it is nothing but equals to the VCC minus of ICRC. Let it be our equation 1. And the collector current, it is equals to the product of saturation current exponential factor VBE upon VT thermal volt equivalent. So this is our equation 2. ये आपका collector current हो गया. Using alpha and beta factors, this emitter current is given by IC upon alpha, and the base current is equals to the collector current upon beta. And I hope you know what is the alpha and beta factors, and if you don't know, then please watch my previous videos also, because it is prerequisite to understand the complete amplification process of the BJT circuits. And one more condition, collector voltage should be greater than VB minus 0.4 volt. Now let's see that how we apply the small signal to the common emitter circuit. So for a small signal operation we have to do nothing extra. आपने DC बायस कंडीशन देख ली, DC बायस कंडीशन से ऑपरेटिंग पॉइंट मिल जाता है. ओके, इन द नेक्स्ट स्टेप अगर हमें स्मॉल सिग्नल ऑपरेशन करना है, इट इज वेरी सिंपल, जस्ट सुपर इम्पोज्ड अ स्मॉल सिग्नल at the input side of the common emitter circuit. So this is our small signal which is superimposed with the VB voltage, and this VB used to bias the base emitter junction in the forward bias mode. Okay, and this is the total voltage at this point, and VB is the our input signal which is to be amplified by the common emitter amplifier. Now let's see that what will be the steps to study the small signal modeling of the BJT. In this series of analog electronic circuits, I have already shown you the small signal modeling of the diode. In the same way, we are going to study the SSM of BJT. But before that, I am requesting you that please subscribe my channel and press the bell icon to get all the notifications of the upcoming videos. Now let's see what will be the steps to study the SSM of BJT. The first step is the parameters. First we will calculate the parameters of the BJT, and then we will draw the models of the BJT, and lastly I will tell you that how we can apply these models in the BJT circuits. So what are the parameters? These are the entities such as voltage, current, dependent sources, or the resistances and the capacitances that are used to model an electronic circuit. But right now we are leaving the capacitances, क्योंकि capacitances का role high frequency small signal modeling में आएगा. तो initial level पे हम voltage, current, dependent sources and resistances को use करेंगे to draw the model of BJT. So the parameters which we are going to study are the small signal collector current, transconductance, the base current, the input resistance. Looking at the base, we call it R pi, and the emitter current, the small signal emitter current, and the input resistance looking into the emitter, and this is denoted by RE. And in the next step we will study the most famous and easiest models of the BJT, that are the pi model and the T model. अगर आपका पाई मॉडल या फिर टी मॉडल किसी एक पर भी कमांड हो जाता है, दैट इज मोर देन सफिशिएंट. एंड इन द लास्ट स्टेप आई विल टेल यू दैट हाउ वी कैन अप्लाई द स्मॉल सिग्नल मॉडल ऑफ BJT on a amplifying circuit. There I will also show you some examples and we will solve some numericals. So these are the steps which we are going to follow. This is going to be very vast topic, so that's why I have partitioned it into the 4 videos. So this was my first video on the topic small signal modeling of the BJT. There I have introduced you the very basics of the signal, the small signal, the operating point, and the DC bias condition, and the how we can apply the small signal to the common emitter circuit. And in the next video I will start with the calculation of the parameters, all the small signal currents and the transconductance and the small signal resistances. Thank you so much for watching this video. I hope you like this video, so please subscribe my channel and share it. If you have any query regarding this topic or any other topic of analog electronic circuit, then please write me in the comment section. I request you to give your feedback. Your feedback is very valuable for me because it motivates me and also helps me to improve myself. Thank you so much and have a nice day.